Hello my friends, welcome back to this short tutorial session, and I will now today talk a little about the balanced dosing methods. In 1984, Hans Werner Belling was doing the first recite, which we call the Belling method, and all recites after that are based on this method. The theory behind is this: when a coral is making its coral skeleton, it formates calcium carbonate. Here we have 3 carbonates in the water, CO3, and we have 3 calcium ions in the water, Ca. When the coral grows, it formates 1 calcium atom with 1 carbonate atom and is building calcium carbonate. It's the skeleton in the coral. You can see here that for 1 calcium consumption, it takes 1 carbonate consumption. So the consumption ratio is 1 to 1. That's a basic behind. So now, when we are dosing this, because this will deplete in the tank due to the coral growth, we must dose in same ratio, of course. We must dose for every calcium ion we will add to the tank, we will add same amount of carbonate ions. So we dose in the ratio 1 to 1. Now we only have one task, and that is to find a salt that contains these 2 ions that we want to add. We can't add just carbonates without adding salt, because that's not possible chemically. So we start with the carbonate. Well, then we take the common salt sodium carbonate, natrium carbonate in Swedish, sodium carbonate. This is like this, sodium carbonate, and we dissolve that and we add that in the tank water. And when we add that in the tank water, that will go back in solution and we have our 3 carbonate ions. That was the purpose. For the calcium, it's the same. We have the calcium ion and we connect that to the chloride. So we have the salt calcium chloride, and then we'll do a mixture of that. That will be added to the tank and then will go back to solution. So we will have the 3 calcium ion which the coral will use. So now we have 2 residual ions that we don't want. We have the sodium ion and the chloride ion. We don't want them. That is a passenger that we want removed from the tank. It's not possible, of course. So how do we do? Yes, we have the sodium chloride that we see as an excess. Then we just add a marine salt with everything without this, and then we are finished. So we take an ordinary marine salt minus sodium and chloride, and then we have compensated for the added excess of this sodium and chloride. So that's the basic behind the dosing methods. It will give no residual ions because we add also that sodium chloride free salt, and it will also add calcium and carbonate in the ratio 1 to 1, in the same ratio as the coral is consuming when they grow. To make it even more simple, we do the recites in that way that the concentration in the bottles are in the same molar. So if you have, for instance, 10 molar calcium in bottle 1, then you have 10 molar carbonate in the bottle 2. The good thing with that is that you don't have to bother the volume how much to dose. You always dose same from all 3 bottles. Or if you have 2 bottles, there are different variations on that. Same basic theory. You base the same amount of volume from all bottles, because the behindness receipt are in that way that you have same amount of carbonate ions per liter, that you have same amount of calcium ions per liter in the bottles in the dosing methods. All existing receipts and all existing ready-to-use solutions from the manufacturer are based on this balanced dosing, that you dose equal from everything. Almost. There are exceptions when these 3 bottles or 2 bottles are not balanced. So you'd have to dose different volumes from each bottle. That is, according to my opinion, unnecessarily complicated, because then you have to measure both calcium and carbonate, and that's not convenient. The good with the balanced method, when you dose equal from all bottles, is that you only have to measure the KH. So you don't have to bother calcium as long as this rule is the correct one. There are small exceptions because we are talking about biology and nothing is perfect. So actually the alkalinity, the carbonates in the tank, can sometimes be consumed or produced by other biochemical processes. But we can forget that for now, because the basic rules are this: we consume same amount of carbonate units as we consume calcium units, and therefore the dosing methods will add in the ratio 1:1, and you tune the Belling dosing schedule according to the kH. That was a little short review, and if you want to read more about this, please refer to literature and maybe some of our own PDFs. Thank you for listening.